In this video, we will be looking at solving two-step equations with one variable. In the previous video, we looked at solving one-step equations with rational numbers. In this video, we will solve two-step equations with rational numbers, and these equations will still only have one variable. So let's just jump right in and look at some examples with whole numbers. So our first problem says 3x plus 7 equals 16. So if we continue from our example in the past, we're going to draw a line to divide the two sides of our equation, and we're going to circle the variable. Now, the first thing that we need to do is figure out, am I going to move the 3 first or the 7 first? And there's two ways to look at this. The first is to look at your order of operations and work backwards. So you'll start by undoing addition or subtraction, then multiplication or division, then exponents, then parentheses. The next other way you can look at it, if we continue with our example with the zombie, is find the number that's furthest away from your variable. So the 3 and the x are side by side, but the 7 is separated by a plus sign. So we're going to undo our 7 first. So the opposite of addition is subtraction. So we're going to subtract 7 from both sides of the equation. A positive 7 and a negative 7 make a 0. So 3x equals 16 minus 7 is 9. Now we undo our multiplication with division. 3 times 3 divided by 3 cancels. So we're left with x equals 9 divided by 3 is 3. We can double check our work by replacing x with 3 and have 3 times 3 plus 7, which equals 9 plus 7, which does equal 16, like we started with. Okay, our next one, we're going to circle our variable. We're going to put a line between the two sides of our equation. Again, the 4 is subtraction. Subtraction, when we're undoing, we're starting at the bottom and working our way up. Subtraction comes before undoing division, so we're going to add the 4 to both sides. So a negative 4 and a plus 4 cancel out and make a 0, so we're left with m over 2 equals 3 plus 4 is 7. We undo division with multiplication. Times 2 divided by 2 cancel, so m equals 2 times 7 is 14. Okay, those are our whole number examples. So let's look at our next one. With integers, so this is introducing negative numbers into our problem. We're going to start the same way, splitting our equation in half. So on one side we have negative 8 minus 3x, on the other side 14. I'm going to circle my variable. I see that the 3 is much closer to the x than the negative 8, so I'm going to move the negative 8 first by adding 8 to both sides. A negative 8 and a positive 8 cancel and make a 0. We're left with, it was subtract 3x, but remember subtraction can be that or it can be negative. So now it's going to be a negative 3x. 14 plus 8. 8 plus 4 is 2. We're going to carry our 1. We get 22. We're going to undo this multiplication with division. So x equals 3 goes into 22 7 times with 1/3 left over. A positive divided by a negative is a negative, or we can give the decimal answer of negative 7.3 repeating. Let's look at our next example. Negative b over 6 minus 2 equals negative 4. I'm going to put in my dividing line, circle my b. The minus 2 is further away from the b, so I'm going to undo subtraction with addition. Positive 2 and negative 2 cancel, so I have a negative b over 6. And in a previous video, when we were talking about negative fractions, we said that the negative can be out to the front. It can be with the numerator or it can be with the denominator. Since I know I will be undoing my division, I'm going to go ahead and move my negative to be with my denominator. Okay, -4 plus 2, different signs tell me to subtract. 4 minus 2 is 2. I have 4 negatives and only 2 positives, so this is a negative answer. Now I need to undo my division. I do that with multiplication. And multiplying and dividing by the same number cancels, so b equals 2 times 6 is 12. A negative times a negative makes a positive, so my answer is 12. Okay, let's clear this and look at our next set of examples, which will be decimals at the starting point and rather than just a decimal answer. Remember, decimals are treated just like whole numbers and integers. They don't have any special rules. So we have 2r minus 1.3 equals 1.7. I've drawn my line. I've circled my variable. I can see the 3.1 is further away. It's separated by the subtraction. So I'm going to move it first with addition. A negative and a positive of the same number make a 0. So we're left with 2r equals 7 plus 1 is 8. Bring down my decimal point. 1 plus 3 is 4. I'm going to undo multiplication with division. Divide by 2. Divide by 2. Multiplying and dividing by the same number cancel. So I'm going to mark this out and say r equals. 2 will go into 4 2 times. 2 will go into 8 4 times, and I will have 1 decimal point in my answer. So r equals 2.4. Our next problem, -5.5 plus 8m equals 10.1. I'm going to put in my dividing line. I'm going to circle my variable. In this case, we can definitely see that the -5.5 is further away. The opposite of a negative is a positive. So I'm going to use positive 5.5. A negative and a positive of the same number cancel. So we have 8m equals 1 plus 5 is 6. Bring down my decimal point. 0 plus 5 is 5, and 1 plus nothing else is 1. I'm going to undo my multiplication with division. Times 8 divided by 8 cancels, so m equals 8 will go into 15 one time. That leaves us with 9 left over. Hold, kitty. Let's just work it out. Sorry, my cat has distracted me. So 15.6 divided by 8. 8 goes into 15 one time. 1 times 8 is 8. 15 minus 8 is 7. Bring down your 6. 8 will go into 76 9 times. That's 72. 76 minus 72 is 4. We're going to add a 0 and bring it down. 8 goes into 40 5 times. That gives us 40. And 40 minus 40 is 0. I bring my decimal point up into my answer and I get 1.95. Okay, and to wrap up, we're going to look at some examples with fractions. Okay, so here's our 2 fraction examples. We start off the same way. We put in our dividing line. We circle our variable. Our 25 is further away, so we're going to move it first. It has no negative or positive in front of it, but we know it's a positive, so we're going to use a -25. Or we can think of it as subtracting 25. A negative and a positive of the same number cancel. So I have 11 over 12b equals 47 minus 25 gives us 22. Now, if you remember in our one-step equation video, we talked about moving fractions to the other side, and we do that by multiplying by the reciprocal or the fraction flipped over. And we do this because when we undo multiplication with division, With fractions, we have to turn division back into multiplication and flip the fraction over. So we save steps and just multiply by the reciprocal. Okay, reciprocal fractions always make a 1, so they cancel each other out and leave us with 1b, or just b. Now let's simplify what we have on the opposite side. I can simplify the 11 and the 22 by dividing them both by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. 2 times 12 is 24. My denominator is 1 times 1, but a denominator of 1 can be ignored. So our answer is just 24. And for our last example, let's put in our line and circle our variable. Again, I'm going to start by moving the 15 because it's further away from my variable. It's a positive 15, so I'm going to use a negative 15. Negative and a positive cancel each other out, so I left with now, rather than minus 1/2 b, I have a negative 1/2 b. Negative 3, negative 15, these signs are the same, so I'm going to add them. 15 plus 3 is 18. They're both negative, so I have a negative answer. Again, I undo a multiplied fraction by multiplying by the reciprocal. Negative numbers, when they're being multiplied or divided, to undo, take their negatives with them. All of this cancels out to make a 1b, or just b. 18 doesn't have anything in the denominator, but our 2's denominator is 1, and we can ignore that now. So 18 times 2 is 36, and negative times a negative makes a positive, so our final answer is 36. And that is how you solve two-step equations with whole numbers, integers, and rational. Thank you for stopping by this Math with Ms. V video. I was glad to see you here today. I hope to see you in a future video.